Hey, hello. Hi. All right, it is time. We are at 9:30, and I think it is time to start the meeting. Could we have quiet, please, in the back of the room? Thank you. We will have open mic time as well. All right, welcome to IETF 119. We are so kicked off in DTN working group. We have Rick, who is joining us remotely. We have Adam, who is joining us remotely. But otherwise, Rick, why don't you take it away with our chair slides to kick us off?
Okay then. So good morning, everybody, or good evening, depending on where you are in your time zones. But good morning, everyone in the room. Next slide, please. Yeah, just for confirmation, this is the DTN working group meeting. If you're not expecting that, you're in the wrong room, and this is your chance to leave. As ever, this is an IETF meeting. It is covered under the note well. Given it is now Friday local time, I'm assuming you've attended some previous meetings and are familiar with the note well. I'm not going to attempt to summarize it better than Tony Lee did earlier in TVR when he said, yes, just be a grown-up, behave sensibly, otherwise you will be invited to leave. And there are circumstances in an ombuds team in order to act as a referee if things get out of hand. But please just be a grown-up and remember, although the subject is exciting, we do need all to get along. The other important part of the note well is to do with IPR disclosure. Anything you say at the mic, you are putting into the public domain. So the onus is upon yourself to make sure you don't breach any corporate or national security guidelines. Next slide, please. There is lots of detail on this you can find by following those links. Note really well, this is the anti-harassment. Please behave. It's that simple. Next slide, please. So meeting tips. We don't have blue sheets anymore. It's 2024. It's all done through MeetEcho. I'm assuming those in the room are signing into the on-site tools so that we can record how many attendees we have. Those of you online, hello. I'm assuming you're using MeetEcho and not some weird audio stream, unless you're watching this in the future on YouTube, which is hello YouTube viewers. Remote participants, the dreaded echo is always the standard thing. Please mute your speaker if you're trying to talk or use a headset. It does work much better. I know in these post-COVID times we are more accomplished at video conferencing, but with a lot of people clamoring and latency involved, please just be a little bit aware with your audio. Next slide, please. So these are the general resources. These are the slides which are provided by the IETF to make sure that chairs have useful information in their slides. And this is the general information. Given it's Friday, if you've got this far and still need help, I feel for you, but it's getting a bit late in the day to try and fix your experience. Next slide, please. So more importantly for this meeting, the agenda. We have quite a packed agenda. So we've got a lot of topics to go through, but most of them we will spin through pretty quickly. The two big subjects, which are almost new work, new discussion pieces, we've got COAP over bundle protocol, which we've left a 25-minute slot for. And we've got a 20-minute slot in there for quality of service extension. And Scott Burley and Alberto Montilla are doing an update on where they've got to with bundle encapsulation. The rest of it, although Brian Sipos has short segments, they sum up to 25 minutes in total to cover the 3 drafts he has in flight. So quite a lot to get through, but we have left 10 minutes at the end for open mic. The one piece of agenda bashing, I wrote these slides based off the agenda that Adam published. The 3GPP SA1 store and forward use cases. Ed, I assume that was you. There was no name attached to it.
Oh, yeah. Yes, that was me. And I can present those at the end.
Okay, perfect. Only other thing to add on the agenda No, let's keep going. Actually, no, I'll do it now. We are changing area directors, so we have to say a big thank you to Zahed, who has done. I can see Magnus is in the room, who's our AD -1. So well done for AD -1 still attending the working group. But on a serious note, thank you so much for Zahed, who I'm not sure quite understood how much he was getting into when he said, "Oh, sure, I can cover DTN as well." He's done a fantastic job, and he will be sorely missed. And we're looking forward to welcoming our new AD, who I believe is officially confirmed to be Eric Klein. He may be in the room. I can't see. My monitor isn't that high resolution. Welcome, Eric, if he's there. And we look forward to more productive work.
So two things in that. One is we do have both Eric and Zahed in the room. And before we go into the AD updates, I do think it would be appropriate to both just take a moment and say thank you to Zahed for all of the work that he has done for DTN, and a deep apologies to Eric for all that he is about to get into for DTN. But thank you, Zahed, and welcome, Eric.
So
there is one other item to agenda bash, and that is Brian Sipos is having a scheduling issue in getting here. Nope, he is here now on time, so we do not need to change the agenda. So I will bash my agenda bash, and we will stick to it.
Okay, brilliant. Next slide, please. So as usual, we need a note taker. Adam takes profuse notes, which is great, but we can't just leave him to do all the work. Critically, can you please check the shared notepad so that if you step to the mic, can you just check that your name was captured correctly and things like that, and that your point was actually captured? Because people speak fast, people get excited, and transcribing is a professional job, and it's not Adam's day job. So although he does a fantastic job, the onus is on all of us to confirm what was captured was actually what we meant. So that's that. And the other thing is, here is the reference to the 2 mailing lists. Please subscribe to the mailing list. It is actually the workhorse of the working group, despite the fact we have meetings and WebEx and virtual interims as required. The mailing list is the critical place for work. So Ed, let me pause and breathe. Do you want to take over?
So these are the documents that we currently have in various states. Just as a reminder, the IPN URI scheme is waiting for the AD go-ahead. The DTNMA, the DTN management architecture is also scheduled for follow-up, and we might hear about that in a moment. We have finished the working group last call. I believe we're now out of working group last call for both the COSI context and the BPv7 admin record types. And I believe Brian will be speaking to those in a moment. And then we have most recently adopted the follow-on specifications to DTNMA, which is the management model and the resource identifier. And we will speak a little bit briefly about that in just a few minutes. So pretty active set, and we have more that are coming. And that is in sort of working with where we are in our milestones. Our milestones are behind. We have too many that are not in 2024, and yet we are here in 2024. So we will have to do a rev of this. But the good news is that for the majority of the work that we did take on in the working group, we are actively progressing almost all of these areas. And that is a good thing. And where we are not progressing, we are working well with other standards organizations who are also progressing in some of these areas, like in some of the signaling work. That's where we are. All right. So with that, what I'd like to do is invite Zahed up to do some outgoing AD updates. And Eric, following that, anything that you would like to say? Up here is fine.
Okay, hello. This is Jahid. I used to edit this working group until last Wednesday. So I have some updates. Like I think it's good to have some record of that one, like where this is, working group stands on different kind of things that we are doing. And then definitely, it's basically Eric will take care of all of the things that we have been working here. So thanks for giving me the opportunity for doing work. It has been really great. So on the working group, update, I think the most important thing here, like now we have been discussing quite a lot, is DTN-MA. DTN-MA went really well in the working group. We want to work with it, definitely. The document is pretty good. We also have follow-up documents to take on some work. It was in the ISG evaluation, we got some comment like this needs some broader kind of attention. So that's exactly what we're doing. I think Ed has been doing a really good job on trying to incorporate all the comments. And also now in this IETF meeting, we have been actually talking with different working groups like NetMores. I think the NetMore session went really well, and there was like general sense like, yeah, this is kind of something good. But the other sense of those thing was like, okay, let's talk about this DTN-MA, about like what we are doing, describe the best practices that we are doing, and try to see like later on what need to be extended. So I think this is in good shape. I hope it goes well. I don't think like we have a serious hurdles to cover right now. So that's it. IPN update. I wanted to send it, but then I thought like Eric can do that. So it just finished its last call. There has been a lot of discussions. So Eric, you need some more information, just reach out to me, or I think Ed and Rick has all the information about IPN update. And that is basically it should go well, unless, and we have been communicating in IANA on this, what we want to do, how we want to do. I think the IANA just told us like, yeah, tell us what to do, we'll do it. So that should be ISG approval of this document would like seal that thing. So that's it. I think the rest of the thing will, I'm really happy to see some work coming on this based on DTN-MA, maybe some young extension. But I also got the feeling that this work needs to be done here in this DTN working group. So that's it from my side.
All right. Thank you so much.
Okay.
Eric, would you like to come up and say anything?
I think I'll just say hello. I know many people I know, but and thank you to Zahed and to the chairs for including me in many conversations this week as we hand over various documents in various states. I think the data tracker is should be completely up to date, I think, with action holders and all the other administrivia. I look forward to trying to do my best to carry these things forward and make sure we get the current documents over the lines and the next ones into the queue. So thank you.
Hey, thank you so much. All right, our first presentation is Brian Sipos, who will be going over 3 topics that are all sort of related to the work that he is doing. Brian, are you online and able to share your audio and video? We'll take that as a no.
He's definitely showing up as there.
Yeah.
So, Brian, your audio is not working if you're talking.
All right, so why don't we take a moment and be delay tolerant and move on with the next set of presentations, and then maybe a little bit later when Brian is better connected, we can go back to his slides. If that is the case, and if it is okay, then if we jump over this, the next thing that we would talk about would be the Constrained Application Protocol COAP over BP. So give me a moment to switch those slides. Okay. I will, this is not working with my laptop, so I will just tell me when to. Thank you.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the initial version of a draft entitled Constrained Application Protocol COAP over Bundle Protocol. My co-author is Ana Calveras. We are both from UPC. Next, please. So this is the introduction, which also provides the motivation for the draft. The first half is pretty much well known by this working group, but anyway, The DTN architecture enables communication in challenged or stressed networks, which are characterized by intermittent connectivity, high delays, high error rates, low energy, low bit rates in some cases. These are features which may be encountered in deep space or temporarily disconnected areas, among others. And then the bundle protocol is the fundamental component of DTN, which provides this store carry forward overlay. And there's the application functionality, which runs atop BP. Then the constrained application protocol, CoAP, is an application layer protocol which has been designed and standardized by the IETF for IoT environments. Many of them are characterized by features like low energy availability, which often leads to intermittent connectivity because the network interfaces, often wireless, have to be duty cycled. And this contributes to high delays. There's also low bandwidth, high error rates, among other constraints. And as you may notice, these features are somewhat similar to those in DTN environments. And CoAP has been designed on purpose for these kind of scenarios. So accordingly, CoAP supports features like lightweight operation. For instance, the message header alone, when not using options, it has a size of only 4 bytes. There's also asynchronous message exchanges, a significant amount of flexibility, as you will see. And CoAP has been designed based on the REST architecture, which is used in the World Wide Web. Next, please. So the main goal for this draft is to specify how CoAP can be carried over BP. Today I'm presenting the initial version. The intended status would be standards track. One related goal is also to explore interest, collect feedback. By the way, there has been already quite some feedback provided, so thanks to all for that. And also another point is that there's a question, which is if there's interest in the document and it progresses, then which is the target working group? Because there would need to be probably 2 working groups involved. The core working group, which specifies CoAP and its related ecosystem, and DTN, which specifies BP and its related environment. So in any case, the aim is to keep both working groups in the loop if the document progresses. Next, please. So back to the content of the document, section 3 provides the architecture. This is the protocol stack model, actually based on figure 1 of RFC 9171. So here we can see the CoAP endpoints are running in the actual endpoints of the communication, the source bundle node, the destination bundle node, on top of the BP overlay, on top of a number of constituent networks from the source to the destination. Next, please. So section 4.1 provides the messaging model and the abstract layering for CoAP over BP. CoAP was originally designed to operate over UDP, and we understand that the same CoAP messaging model would apply also over BP, because both UDP and BP are message-oriented protocols that do not support retransmission. CoAP was subsequently extended to operate also over reliable transports, such as TCP, TLS, and WebSockets. However, for that, there's a different messaging model, which we understand is not so suitable. Next, please. So CoAP can be viewed as comprising 2 sublayers. The uppermost one handles requests and responses. The requests are sent by clients which aim to manipulate resources on servers, and then the servers bring responses back to the clients, in some cases including a representation of the intended resource. And these requests and responses are then encapsulated as messages, which are handled by the lower sublayer called messages here, which offers, broadly speaking, optional reliability and simple congestion control. So there are 2 main message types. The first is confirmable CON messages, which must be acknowledged by the receiver, lead by default to a stop and wait pattern. And there is timer-based retransmission with exponential backoff as simple congestion control measure for these CON messages. Then there's also non-confirmable messages, which do not elicit acknowledgements from the receiver. There is acknowledgements themselves, and also the special case of reset messages, which are sent when a receiver gets a message that it doesn't know how to process. Next, please. So also in this section 4.1, we have attempted to provide some perhaps minor optimization. The idea here is when a source bundle node has to transmit a co-op con message, then it may set the request reporting of bundle delivery flag in the encapsulating bundle, and then the receiver may opt to only send the corresponding bundle delivery status report instead of sending a bundle encapsulating the co-op ACK message. This is only for the case where the co-op ACK doesn't carry a payload. This can happen when a request well, there's not a response ready when a request arrives, but still the confirmation needs to be sent, or when there's a con message which does not elicit an actual response. So here, then the status report that would be sent in response to this bundle encapsulated con message would serve as a co-op ACK for the con message. So the assumption is that the status report size would be a bit shorter than the size of the bundle encapsulating the co-op ACK message with no payload. So there were some comments by Brian in this regard. So we expect that here, this saving a few bytes would compensate the perhaps additional complexity of handling the situation. Perhaps, well, there are some additional things to discuss here. Next, please. So Photo 2 provides the message format. First of all, regarding how the co-op message is carried over BP, we state that the co-op message must be carried as the block type specific data field of the bundle payload block type 1 of the corresponding encapsulating bundle. And then regarding the co-op message format itself, each co-op message has a field called the message ID. And then we are considering extending the message ID size from 16 bits, which is the default one, to 24 bits. This is intended to avoid a perhaps severe limitation on the maximum message rate for a sender. This is because RFC 7252, which is the base co-op specification, states that the same message ID must not be reused within the exchange lifetime, which is the time that with the default co-op settings is equal to 247 seconds. And however, in other environments, like for example, in say deep space environments, this time should be at least in the order of thousands to perhaps tens of thousands or perhaps even more. So then it means that with the default settings, the maximum message rate would be 265 messages per second. However, if we consider communication from Jupiter to Earth, this would decrease down to 3 messages per second, assuming only one retry for con messages, which is a favorable setting. So yeah, this is why we want to avoid at least this maybe too constrained on the maximum message rate for a sender. Next, please. Section 5 discusses co-op parameter settings, which may be relevant. Nstart is the maximum number of outstanding interactions between a client and a server, an outstanding interaction being a request and its corresponding response, or a con message and its corresponding subsequent ACK. By default, the setting for this parameter is 1, which leads often to the stop and wait pattern in co-op. Then the base co-op specification explains that greater values are possible if there's some mechanism that ensures congestion safety. So it's an open question which should be the right setting for this parameter in DTN environments. Then there are two parameters, ACK timeout and ACK random factor, which are both relevant because they determine the initial value for the retransmission timeout. This is randomly chosen from the interval from ACK timeout up to ACK timeout multiplied by the random factor. The default values are for ACK timeout, it's 2 seconds. However, for example, the RTT between Earth and Mars is up to 45 minutes, considering only a propagation delay component. So of course, this parameter would need to be set to at least the RTT in the particular scenario. And ACK random factor is by default equal to 1.5. This is intended in the original co-op specification, the base co-op specification, to avoid synchronization effects, which may occur when there's like a group of sensors which may be transmitting sensor readings periodically. They may be close to each other. And when the scale of the latencies is relatively low, it is somewhat likely that several devices might end up colliding repeatedly all the time. So this parameter is intended to avoid to decouple that effect. And however, when we are dealing with much greater latencies, then perhaps it's very unlikely that synchronization will happen. So therefore, in that case, perhaps it may be better to reduce the random factor to just 1.
Do you want to take questions in line or wait till the end?
As you prefer.
Okay. We have Rodney in the queue. Okay. Oh, go ahead.
Hi, Rod Van Meter. Can you go back to page 8 for just a second? I'm only a dilettante here, so this is probably, you guys have probably talked about this or covered this already, but the exchange lifetime says deep space up to 10 to the 4th seconds. That's only 3 hours, which is plenty for the actual time of flight, but in my limited understanding, when you have to wait for like orbits to coordinate for relay, that's not enough for end to end. So is that the right time value, or does it only have to be the time of flight number?
Yeah, so you're correct. Probably we need to incorporate as well, because here we were rather considering a sort of idealized scenario, kind of referring to what we have in Appendix A, which only considers propagation delay, but definitely we need to also include, like you said, other delay components. So yeah, perhaps these numbers need to be just increased and make it clear that, well, this is like in the best case, let's say, like considering only propagation delay.
Yeah, my first reaction on things like the message ID is just don't use such a small number, but I know that for your application use that actually every bit kind of matters. But
yeah, so that's the trade-off. Actually, in the design of CoAP, there was this concern of providing some very lightweight message format. So increasing 1 byte is somewhat relevant, at least in that area. We should maybe try to see globally whether this is an issue or not, or maybe it's kind of negligible somehow. But yeah, anyway, if on the other hand, if we might be constrained in terms of the message rate, we might need to increase the message ID. So yeah, we have a trade-off. Yeah, thank you.
Thank you. And we have one more. Rick is in the queue.
I just wait for my audio to wake up. Is there any reason, given that a bundle does actually have a unique message ID and it's made of the concatenation of source EID and timestamps and it has a sequence number built in to the primary block of a bundle, could you delegate the message ID field and say, actually, it's 0 bits? Use this other thing that's already in the bundle, given you've got a mapping of a message, a one-to-one mapping of a message to a bundle. Do you need a secondary message ID is my question.
Yeah, thank you. That's something we had actually thought about. Perhaps one thing to consider is when we have con messages, which might lead to retries from the source, then understand that perhaps the message ID would be the same, but then it might be encapsulated in a different bundle. Yeah.
Yeah, I see. So it's the sequence of the message within some longer conversation rather than the unique identifier of the bundle. Got it. Thank you.
Yeah. Thank you. Okay, so then the next parameter was max return Smith. This is the maximum number of retries for con messages. It has a default value of 4. However, perhaps due to the exponential backoff that there is with retries, maybe a lower setting, a lower value than the default one might be suitable. And related question is an open question, actually, whether we might need congestion control at all in the environments where BP is used. Next, please. Then still in section 5, there are some related times. One is max latency, which is the maximum time since a datagram is sent until it is received at the destination. It is defined as 100 seconds, which is close to the 2-minute maximum segment lifetime defined in the original TCP specification. Then another one is exchange lifetime, which is the maximum time since the first transmission attempt of a con message until the arrival of its corresponding ACK. By default, this would be, with default settings, 247 seconds. And non-lifetime has a maximum time since a non-message is sent until it is received, which is by default defined as max latency, which is 100 seconds. So again, aligned with what has been mentioned before, yeah, we may need to extend the values for these times by at least maybe 2 orders of magnitude greater than those by default when using CoAP over BP. And one note is that CoAP implementations using 8-bit timers to compute these related times may need to be adapted to operate over BP, perhaps using larger variables to account for the greater latencies. So section 6 discusses a CoAP option called observe, which is very useful because it allows a server to send notifications carrying a representation of the current state of some resource to interested clients, which are called observers. The latter only need to initially register their interest in some particular resource, and then whenever the resource state changes, then the server will transmit a notification carrying the current state of the resource to the client, and that is without the need from the client to send a specific request for that. So this is, of course, beneficial in scenarios with high latency and or low energy or bandwidth. There is one detail in the original observe specification, which is that if the time between the 2 last notifications that a client has received is greater than 128 seconds, then the last one received is or can be considered the latest one sent. However, this time 128 seconds is chosen as a value greater than the default max latency, but when CoAP is used over BP, probably this amount of time may be insufficient in many cases. So the duration here would need to be chosen as a value greater than the max latency of the particular scenario. And well, there are some related details in Appendix A. Next, please. So section 7 focuses on blockwise transfers. CoAP supports functionality that allows carrying large payloads by means of what is called blockwise transfers. It's a sort of fragmentation and reassembly at the application layer. So on the other hand, BP also supports its own mechanism for fragmentation reassembly. There is one statement in the original blockwise specification for CoAP, which is 7959, which is that the fragmentation reassembly process burdens the lower layers with conversation state that is better managed in the application layer. There is one implicit assumption there, which is that the details on the data unit sizes that can be carried along the path over the different links are known in advance. However, well, perhaps it's open for discussion whether this statement still holds when running CoAP over BP. Anyway, in the draft, we have currently added that for CoAP over BP as an option, CoAP blockwise transfers may be used if the source knows in advance the duration and type of expected contacts. And this does not preclude the use of BP fragmentation and reassembly whenever necessary. And there are 2 specifications that define CoAP blockwise transfers. And we understand that the second one, which is RFC 9177, is more suitable because the original one in principle leads to a stop and wait pattern, and also the last one supports efficient loss recovery. So we understand that it's more suitable for the environments where BP is used. Also, there are several parameters for this particular specification which may need to be fine-tuned to each scenario. Next, please. So in section 8, we focus on a CoAP over BP URI scheme. So there are several CoAP URI schemes that exist already. The original CoAP specification defines CoAP and CoAP-S as schemes. Then RFC 8323 also defines the schemes to support CoAP over TCP, over TLS, and WebSockets. And here we attempted to define a new URI scheme for CoAP over BP, which would have this name CoAP plus BP. And the syntax would be the one shown on the slide. And here the syntax that would apply would be similar to the one in the original CoAP specification, except for the endpoint ID part. However, we received some comments on Wednesday in the core working group meeting that perhaps it might not be necessary to register a new co-op over BP scheme. Perhaps it might be enough to use a co-op scheme as long as there is some way to tell unambiguously that well, whatever should be the endpoint ID is not confused with maybe something else. There is also some work in progress document in the core working group, which is trying to provide some guidance in this regard for co-op over alternative transports. BP is one of those. So yeah, this is something we have to double check and perhaps update for the next revision of the draft.
And I see Rick in the queue.
Yeah. So just touching on the comment about endpoint IDs, it's important to remember with bundle protocol, we have two different schemes for endpoint IDs. We've got a numeric scheme and we've got the DTN scheme, which is text-based. Both of those already have a URI representation. So whoever commented in the core working group that just co-op and then understanding that the endpoint ID part could be discriminated correctly is correct. I don't think you need a co-op plus BP. You might need a co-op plus DTN or a co-op plus IPN, but I think just having co-op is the right way to go. Happy to continue that conversation on the mailing list.
Okay, thank you. Thank you very much. Yeah, so, well, section 9 is the IANA considerations. However, these contain the request to register the URI scheme, which perhaps will not be present in the next version of the draft, if this is confirmed. So next, please. Yeah, so finally, there are also a couple of appendixes in the draft. The first one, Appendix A, tries to provide some sort of reference parameter values regarding delays and related times, in this case, for the examples for interplanetary communication, for times between two celestial bodies of the solar system. Here, these are idealized scenarios. Latency here only comprises propagation delay. Anyway, the aim is to provide some reference to show what are the orders of magnitude we are dealing with here, because these are quite different from the default ones, for example, in co-op. So these times may be something more familiar, more common for DTN, but maybe not so much for the core working group. And for example, this table provides RTT values, which also would be something like the minimum ACT timeout to be used in that specific case, or the equivalent exchange lifetime for max retransmit equal to 0. And as you can see, the orders of magnitude are thousands or tens of thousands of seconds. Yeah.
Just a comment while you're coming to the mic from the chat, and as a member of the New Horizons team, where's Pluto? Rodney.
I was just going to point out that I just checked, and Voyager 1 is currently 22.5 hours one-way latency. So I would suggest we have protocols that are capable of going out a little farther.
Thank you.
Okay, thank you.
Magnus.
Magnus Westland. I want to comment on, I think, the whole congestion control, flow control, repair schemes. It seems like here we need to think a little bit about how you do this, because, I mean, convergence layer is supposed to take care of the congestion. So I think what comes down for co-op is the question saying, your endpoint, how many concurrent requests can it handle? How many total messages are you willing to burden the paths with, etc.? That's more the like kind of limitations you have. So I mean, sending as much data towards the bundle protocol here should be fine. And I mean, from that perspective, so I think it's you need to think about, okay, how much can you commit, and what can you deal with. Also, when it comes to the repair, etc., I mean, I would guess you have to scale it to, or in relation to what bundle protocol lifetimes you set. So that, okay, what's the maximum lifetime, and when do I need to retransmit based if I haven't received a response? So
yeah, thank you. There were also comments on the list, I think, regarding the bundle lifetime. So yeah, definitely something to look at as well. Thank you.
Then we do have Joshua in the queue.
Hey, can you guys hear me?
Yes.
So I may have missed it or I might have a bad assumption here, but has there been any consideration towards the possibility of aggregating multiple CoAP messages into a single bundle to try and increase efficiency across BP?
Yeah, so that's a good suggestion. So in the draft, we are not currently considering that, but perhaps it might be something to look at for efficiency, yeah?
Thank you. And Rick.
Chair hat off. I really support this work. I think this is really good stuff. It's really nice to see application layer protocols being built to run on top of bundle protocol. I'm very happy to. I'm going to go back deep into this document after the session. I'm going to come back with a lot more comments because I want it to work. I think the guiding principle is to look at the information that is already in the bundle protocol primary block or available through extension blocks and try and avoid duplication, semantic duplication with what's in the CoAP headers. But I think this should work. I think this really should work. So I really support it, and I'm offering to help, and I will contribute to this. Thank you.
Thanks a lot.
And Scott.
Sharing my audio. Hi. I had two thoughts. One was just to suggest that you maybe contact people at Antara Technic, a little company in Northern California, who have an implementation of CoAP over BP that is not open source, but there may be some experience that you can build on from what they've built. But my main comment is on the use of confirmed messages, and I will suggest that it might actually be simpler, avoiding a lot of configuration problems, to use non-confirmed messages instead and rely on bundle protocol being reliable and congestion aware substrate, not innately, but by virtue of the convergence layer protocols that it runs over. I think that there is some likelihood of a status report message is being used as an acknowledgement being lost because it's not sent reliably itself. I think the likelihood of that happening is at least as great as the likelihood of a failure in reliable transmission at the underlying layer underneath bundle protocol, and that would save problems with trying to estimate round trip time and timeout intervals, and the limits on the different message numbers that you use to identify the messages. I think a lot of problems go away.
Okay, thank you. Yeah, perhaps it may be good to discuss further whether that would mean like to completely discard like the option of using con messages, or maybe perhaps in some cases they might be used. But yeah, definitely we may position a bit the text in the lines of the comments that you just made.
Thanks.
Thank you. Okay, so finally, there's Appendix B. It's just some numbers trying to illustrate a bit why we might be interested in increasing the message ID size in the CoAP header. The column on the left is a series of exchange lifetime values. The one in the middle is the maximum message rate for a message ID of 16 bits. And the one on the right is the maximum message rate for a message ID of 24 bits. So as it can be seen with different values, if we want to avoid a quite significant decrease in the maximum message rate, then it may be good to use 24-bit message IDs. So that's my last slide.
So a quick question out to the working group, and that is, I know that this is not a call for adoption, but are there any, while we are here together, both in the room and online, are there any concerns about the approach of standardizing COAP over BP? All right.
Eric Klein, speaking only as the AD, I think the only concern is that we maintain communication with, I guess, core working group. Is that where?
Yeah.
Yeah, just be sure we have their review at critical junctures. Everything should be fine.
All right. Thank you, and thank you very much.
Thank you.
Brian, if you are able to talk over audio, can you let us know that? All right. Let us continue on with the bundle-in-bundle encapsulation updates. Here.
Thanks, Ed and folks. Can you hear me?
All right. Give me a moment to set your timer.
Can you hear me now?
Oh, yes, we can hear you.
Oh, thank you. Thank you. So bundle-in-bundle encapsulation, wanted to provide you with some updates together with Scott and Joshua, who are on the call as well. So let's go to the next slide. Motivation, as many of you know, the existing draft for a BIBE as a convergence layer expired in August 2020. We have resumed the work on a BIBE on the draft, and a new proposed version is expected soon. We're working on it. We don't have an exact date, but moving forward, the original motivation of BIBE was primarily about extending security, enabling defense against traffic analysis, as well as allow things such as cross-domain security, source path forwarding, and things of that nature, as a way to support, interim security destinations. We're adding three additional aspects to this motivation. The first one is that we at Spatian believe that BIBE is key to service provider DTN networks, and we're going to be demonstrating BIBE in the ISS later this year. There is also a use case related to migration from BPv6 to BPv7, and CCSDS is working on an Orange book to describe the DTN implementation of BIBE for carrying over BPv6 over a BPv7 network. So basically migrating the network to BPv7 while keeping the payload bundle protocol or DTN nodes on BPv6. And last but not least is basically driving requirements convergence for the initial 3 implementations available, including Ion DTN and Micro DTN. So I'm going to go and talk on the next slide, talk about the first motivation, which is our new motivation, which is BIBE within the context of service provider networks. And what you see on the screen is basically a division in which you have the end user domain, and then in between the service provider domain. And domain here is used loosely, has no direct relationship to the bundle protocol specification or to the BIBE specification by any means. This is more related to us, how we see as service provider networks, and things such as using BIBE as a way to allow the service provider to apply their own security policies. Because at the end of the day, the service provider is responsible for their own network, but that also applies to their routing policies, to their quality of service policies, and the likes. In addition to that, BIBE offers the possibility to hide the topology, especially the networks that are inside the service provider domain, so that it simplifies routing configuration and also provides just another layer of security of its own. So the whole idea is that the end user domains, they basically see the entry and the exit gateways. They don't have to see the routing path because that belongs to the BIBE domain. So in this example, node 11 would basically communicate, let's say, with node 21 to the service provider network, and all they know is the exit gateway, which in this case is the node 1. And then the node 11 could have their own quality of service and security, and this can be encapsulated on Vibe, and Vibe itself would have its own policies, or the Vibe bundle would have its own policies as well. So we're going to be demonstrating a part of it in the upcoming technology demonstration, and we do believe it is an important factor to consider. So Scott, who's going to be next, is going to talk about one of how some of this is currently implemented in Ion. Scott?
Yeah, good. Thanks, Alberto. Here's just a brief overview of some changes in the implementation of Vibe in the Ion implementation of bundle protocol. The motivation here is that, in particular, looking at the service provider network use case and the security use case, where you might have a particular security domain that needs to be operated in a significantly different way from the edge domains where information flow is more secure. In order to make those things work, what we've determined is that it's important to give the Vibe bundle source, that is the encapsulating nodes, real control over all the parameters that condition the forwarding of the Vibe encapsulating bundles. And so what we've done in the Vibe implementation in Ion is enhance the Vibe administration function. There's always been this notion of a VCLA Vibe, convergence layer adapter, a configuration object that is managed using the Vibe admin utility to set up some parameters governing the transmission of the encapsulating bundles. That's expanded now to include values that would be used for all of the parameter values in the outgoing encapsulating bundles. Those are things like the request for status reports, a report to endpoint ID, a flow label for the encapsulating bundles, sort of in addition to the other quality of service parameters that are provided for transmitted bundles coming out of Ion nodes. There is a provision of RFC 9171 that prohibits the issuance of status reports for bundles whose payloads are administrative records, and that was intended to avoid the kind of hailstorm of status reports that you could get from generating status reports off of status reports off of status reports. This is a little bit of a problem here because the structure of the Vibe implementation and the original specification in the now defunct interim internet draft for Vibe was that the payloads of the encapsulating bundles would be administrative records, and the administrative records content would be the encapsulated bundles. Well, that would make it impossible to provide status reports for those encapsulating bundles, which is an important capability if you're doing a service provider network. And so what we're proposing, along with the change to the implementation, is an additional bundle processing flag that indicates that the payload is Vibe, and where that is the case, that is intended to introduce an exception to that rule in 9171. Next slide.
Before we go on, we do have Rick in the
Oh
queue.
yeah, Rick. Hi.
Hey, Scott. Very quick question about the admin records for bundle encapsulation. Your third bullet. In my mind, bundle encapsulation, although the payload happens to be an admin record that's traveling effectively through your tunnel, because bundle is tunneling.
It is.
Yeah. Surely even though the payload is an admin record that you are tunneling, surely you wouldn't set the bundle flag in the primary block to say this is an admin record, because it's not an admin record when it's inside the bundle. Do you
Well,
need
it's
to change 9171 here?
it's still an admin record because um, the when it is received at its destination, when the encapsulating bundle is received at its destination, the payload of the encapsulating bundle needs to be delivered to the bundle protocol agent, not to anything else that is in the user area. So the bundle protocol agent is going to receive this thing, and the only thing that the bundle protocol agent receives in its capacity as a destination is administrative records. And we can introduce like new ways of
I've got
doing this, but
lost.
this is like the simplest way to do it, I think.
Yeah, I just get wary about changing 9171. I think a diagram would really help. I've got lost about what's being promoted and what's not, and when it's end-capped and when it's decapped.
It is totally the case that the diagrams are very helpful with bundle and bundle encapsulation. Your mind just breaks. But I think this is and we do sort of have the ability to introduce new bundle processing flags and so forth. That's anticipated in the spec, and I don't think it's departing too far from the intent of the specification to allow an exception in this case.
That's absolutely fine. I suppose where my challenge is, and I understand this is work in progress, and I need to do a bit more reading, was that with once encapsulated, the content of the payload is opaque until the decap point, and that was the point that Alberto made about transiting through secure environments, and hence the less you flag into the outer payload to say, the more transparent you make that allegedly opaque payload, the more worried I get. But I'll leave it for now. This is something I've made a note. I need to review this.
Right. We do have a flag that says that the payload is an administrative record. So we do say something about it no matter what already. And this is I understand your reluctance, and if we can find another way to do it, that's fine. This was the simplest way I could think of.
Fine. Let's take this to the list, or I'll wait for a bit more information.
Sure. Next slide, then. And I believe this is our last slide, and it's just a summary of the work that Josh Deaton and folks at Marshall Space Flight Center are doing with DTN ME. Josh, would you like to speak to the slide?
Yeah, I can talk to this. And thanks, Alberto and Scott, for divvying up a small amount of time for me to talk about this part. So for DTN Me, we incorporated Bibe, particularly for our use case, was the encapsulation of the different versions, as that was one of the main hurdles of trying to deal with deploying V7 on the ISS while also still maintaining legacy support for our already existing payloads. And we do agree that the current standard does allow for the encapsulation of V6 bundles by V7 bundles. But one of the things that would need to be updated if we wanted to maintain both directions would be that a definition of a pseudo BPv6 Bibe administration record would need to be defined potentially in an NX just to make sure that that could actually be covered under the standard, so that could be used properly. And that's really the main thing. We did implement it as that intermediate convergence layer type concept, as Scott was talking about. And the only other special things that we particularly did was we added some redirect options to our current convergence layers instead of having to directly point out the Vibe convergence layer. And I'll give it back to Alberto.
Thanks, folks. And that's basically the update we wanted to provide. What is next is that we will be basically delivering the draft once ready. Thank you.
All right. Thank you so much. And looking forward to the updated draft. Right. Next on the agenda, we will have a quality of service extension for bundle protocol. And I believe that Teresa, you will share your screen.
Yes, I will be sharing my screen. I already see my screen.
No, there's a permission thing that I need to click, but I'm not seeing. Give me a moment. Rick, do you see where the permission to share screen is?
Let me try and find it. So video is published and audio is published and slides are published. It should be there.
Oh, I can share directly from here.
Yeah.
Oh,
Yeah,
great.
just do it from there. It's all within Meet Echo. You don't need to share your screen. It's not. It's way ahead of
Great.
Zoom. Thank you, Meet Echo.
Yeah, this works very well. Okay, so good night from Germany. My name is Teresa Algarra, and I'm working on quality of service for bundle protocol. This is my PhD. I'm a second year PhD student, and I am working on implementing this into an extension block. So I am going to go over my proposal. Yes. So I am working on quality of service over VPN in general, but I am mostly focusing on the scenario of Earth to Moon communications. This is a very present scenario. And the truth is, in the near future, we're going to have congestion, since we will have, for an extended period of time, only one relay link, one relay satellite in the middle. We expect to have many different types of interconnected devices, as well as many types of traffics. And in the future, we will also have several networks that have to interact with each other somehow. So with using bundle protocol, we also have a need for quality of service management, and that is why I am proposing an extension block that does this for bundle protocol. So this would go into an extension block, but not only one extension block. My proposal is having two extension blocks. This arises from many comments that I have received previously in CCSDS, since this work is currently being carried out at the CCSDS, and I am working on an Orange book that will be proposed soon. So there would be two extension blocks, one that is called user quality of service extension block that can be present only one time, and this would be defined by the source, including parameters such as traffic prioritization, required reliability, and so on. So this is what the node says. This is my bundle. These are my parameters. And then we would have the network quality of service extension block that can be present more than once, and it is always served as local values, meaning the networks get to decide to append a block saying this is maybe network prioritization or some other parameters that they see relevant for according to their priorities. So, oh, my slides are a bit, okay, we can work with it. So how both of these blocks would be structured, they would be very similar. The only difference being the user quality of service extension block would have only the canonical block extension information, because the inserting node is the source already, so that's already in the header. Whereas the network quality of service extension block would have to include also the inserting node ID, because this can be added and removed along the way. It is the dynamic part of this information. And both of these are going to be using CBOR maps to have the type of quality of service parameter that we're currently defining and the value. So for example, there would be a map saying traffic prioritization is critical, and then required reliability is blah, blah, blah. Using CBOR maps takes the exact same amount or same space as using CBOR arrays, and it is very useful in the sense that we would always have the pairs matched up with each other, eliminating a possible error. Yeah, so moving on to the definition of both blocks, we would start with user quality of service extension blocks, since this is the one that is the most defined. As of now, there are 3 parameters that we have identified as relevant. We are aware that these are not all. These are, however, the ones that are currently being defined for this CCSTS Orange Book, starting with traffic prioritization, for which there are 3 main types defined. One is critical, which would be, I believe some people call it a 911 type of information. And then following some of the guidelines, there would be a distinction between quasi-real-time and store and forward. Both of them have a range of numbers, meaning that there can be sub-priorities within these types, and they can be managed. The values have been assigned 0 to 23, meaning 24 values, because then this would only take 1 byte with this CBOR encoding with a map. The rest are left as unassigned, but they could be used in an extension in the future. So how would this queuing work, which is always the big question. So as I said, there are 3 queues to be defined. The first one is critical, second one is quasi-real time, meaning if there are any bundles that are considered critical in the queue, they must be served before moving on to quasi-real time. Then if there are any bundles that are quasi-real time, they must be served before moving to store and forward, and store and forward would only be served if there are no other types of bundles in the queue. However, since there are sub-priorities within each queue, within each queue there would have to be weighted queuing to avoid data starvation. So if there are critical bundles, no quasi-real-time bundles are going to go through until there are no more critical bundles. However, if there are 3 types of quasi-real-time bundles, there would be some kind of weighted queuing to make sure that the ones with the lowest priority still get sent, even if it's at a slower rate than the higher priority ones. So yes, we would have an importance or urgency decrease in this table. The second parameter would be the required reliability. That is, if the bundle needs to be sent over a reliable or an unreliable link. It has been previously defined as a binary flag, sort of either reliable or unreliable. We thought it was also interesting to add not only strictly reliable or strictly unreliable, but also reliable if possible and unreliable if possible. So if there is the chance of transmitting it reliably, it should be done that way. If not, it can be done unreliably as long as it is sent. So now it's a little bit more complex. However, this is still only 4 values that are being used, and the rest are reserved for future use, since there might be the need to do a little bit more granularity for some specific scenarios. And the last one is latest only. I believe this was touched or mentioned before. If we have, for example, a series of bundles that come, there might be the chance that only the last one is valid. With this flag, this would be a binary flag, either it's up or not. Only the last one would be valid, and the rest would be dropped from the queue. This is also work in progress. So there is someone else that is working on this latest only concept. So there are the rest of the values that are not from the binary flag are reserved for future use, but there is also the chance that this may change if the system gets more complex or if again needs more granularity. Yeah, so as an example of execution, if we had a source in yellow and a destination in blue that have to go through a node in green, and we had three bundles, bundle one would be quasi-real time and needs to be sent reliably. Bundle two is store and forward and needs to be sent reliably. And bundle three is quasi-real time again, but can be sent unreliably. Then in the queue, given that there's only one link, 1 and 3 would be sent before 2, since 2 is store and forward. And then in the chance of having two possible links, reliable and unreliable, or sorry, two manners of transmitting the information over the link, B1 and B2 would be sent over the reliable link, and B3 would be sent over the unreliable. Yes, the other part of the proposal is the network quality of service extension block. This part is really short because it is really reserved for local use and for each network to define the quality of service parameters or the parameters in general that are important or relevant according to their priorities and to assign values to them. And what this would mean is that this block could translate the user quality of service extension block into internal policy, therefore optimizing the decision process for the intermediate blocks of a network. So it's just an addition to the other one. And yes, all values are reserved for local use to give the individual networks maximum flexibility. What this means is that we would have one block that is immutable, and it would be authenticated with the primary header, primary bundle block. And then we would have this network quality of service extension block, which is dynamic. An example of use would be here. A similar example, we have one source that is in one network and the destination that is in another network, and we have to traverse a second network here in green. So if we were trying to send a bundle with a certain traffic prioritization requirements and required reliability, and we went on to network 2, this would append another block that would say, okay, I am the gateway of network 2, and I say on top of this, this also has this network priority, for example. This bundle or this extension block would be kept along the second network, and the moment it would exit the network, it would be deleted because it's not relevant anymore towards outside of the network, and then the bundle would be transmitted only with the user quality of service extension block onto the destination. So just to recap, we would have, of course, any extension blocks that might already exist, and on top 2 extension blocks, the user quality of service 1 and the optional network quality of service extension block. The user quality of service extension block would be within the integrity check, and the network one wouldn't be. So that is my proposal, and I am very open to questions and comments.
All right, thank you very much. And we do have a couple people in the queue. First, Alberto.
Teresa, thank you for the presentation. I'm wondering if you consider or validated or compared this option with an option in which you don't have a network extension block, but just have a policy on the node. I'm curious about why carrying a new extension block within the network, because at the end of the day, might be a mapping. The mapping might be pretty static along the way, from either derived from the user, a quality of service block or extension, or just simply based on whatever policy the network has for that type of quality of service. So I'm wondering about the motivation of including the network extension block.
Yes, so my initial proposal was without the network block. I added that because of the feedback I received during the CCSDS meetings, in which policy would either be incredibly complex and not scalable, or would miss some of the cases. So this policy would not only have to include how the network treats a certain, for example, traffic prioritization or required reliability, but also the source, the network where it comes from, and a lot of other characteristics that would mean a very complex policy, and it would work in the case where we have a low amount of devices, but the moment that we have a growing network, that it's growing, it's going to grow exponentially at some point, or it's going to grow much more at some point, then it would be really not scalable.
Okay. Okay. I understand. Thank you.
And Joshua?
You may have mentioned it, but I'll go ahead and ask anyways. Did you discuss the reasoning for putting the node or inserting node ID on the network block versus just depending on the a bib to identify that fact?
So that was initially chosen because to avoid, for example, one network block going into another network, maybe. So it would be clear to identify, okay, this is belonging to our network, or this is from another network, and this block can be dropped.
So I guess kind of again the question would be, why couldn't you just simply use a bib to identify that fact and drop both when you need to throw it away? And then the user and network block both have the same primary part. And even to that extent, the extra piece that you had for the network extension block, you could just do as an optional element to the user block. And now you just have one definition for an extension block and you're done.
I'm sorry. So the part about just using the bib, that's something that I actually hadn't considered, and I will look into it. Thank you very much for the idea. The second part about just having one, you mean having the network part inside of the user block and just dropping that part, you mean?
Yes. So the network specific pieces that are only in the network extension block right now, just make it as an optional element to the other extension block. And then now you're not defining two separate blocks. It's one block with an option.
So the problem that I saw with that is that then the block would have to be dynamic, and there would be no way of checking that the original content has not been modified along the way.
We can take this offline. Yeah. Thanks for the discussion,
please.
though.
Thank you.
And Rick?
First off, great work. I really like this. I'm also going to say thank you for splitting the user block from the network block, because when you have big heterogeneous interoperable DTNs, which I know I'm trying to build, and it's sometimes very easy to get focused on, well, we just have a simple network at the moment. We know from DSCP based QoS on the internet that as soon as packets leave an administrative domain, people immediately take off the QoS, because what's important to you is not important to me. So I really like the fact, and this is kind of going back to Joshua's point, if the application, which is the user in this case, can say, I consider this data important to me in the following manner, and that can be using a bundle integrity block that can be secured, authenticated, and placed in an immutable way for the lifetime of that bundle. And then the second block can be added and removed as it transits different administrative domains. They can make their decisions about how they wish to treat it without losing the original. That is spot on. That is such a good way of doing it, and it's bothered me that we have avoided this before and said, oh, we'll have 4 bits, it will be fine, and it was never going to be. So I really support this, and I really support that split into 2 blocks, and I understand why you're doing it. Thank you.
Thank you.
All right. Thank you. Thank you very much.
Yeah, thank you.
All right. Next, the next presentation is going to be the block of presentations for Brian, and we will give just one more chance on that. If not, I will walk through the slides, having some familiarity with them, and we can take questions to the mailing list or otherwise make sure that things go into the chat itself. All right, so I am not Brian Sipos, but I will be for the next few minutes. And I wanted to talk about 3 different things. The first one is just sort of the status of the BP version 7 administrative record updates registry. So if we recall, this was a document to update that registry. We have done a last call. Well, we are still in the working group last call state. I believe we have probably finished the last call, and we need to update that document. It technically expired last month, but we have no comments that no comments were received during the last call, or edits are expected to be needed. And it is starting to hold up work that's happening in Acme. So here, having gone through the working group last call, we're ready to call that. Although, since we are in the room here and online, are there any concerns with this document? Speak now.
I'm going to add one thing, which is I'm not sure, and I'm looking at our 2 previous and 1 current AD for advice here. Can we proceed to the IESG review phase with an expired document?
There was talk about changing the data tracker so that things just really don't ever expire, because in fact they don't expire. The data tracker keeps them around forever. So what is a draft that's kept forever versus a draft that has an arbitrary tag that says expires on it? That said, it shouldn't be too difficult to just, I guess, yeah. But
Okay.
no, I wouldn't necessarily have a problem with it. So actually,
Thank you.
It's in working group last call state. Yeah, it has to go to AD eval. There might be some updates for that, and then IETF last call. So it'll need to be revved before it gets to the ISG anyway.
Okay. I think the last call expired. I think we ran that properly as chairs. I just never clicked the button in the data tracker. So my apologies.
Yeah. Well, and one thing that we are still actively looking for, either from DTN working group or maybe Acme, is a shepherd for this document. So if you are interested in being a shepherd, if you have read it, if you are tracking it, please let us know. Otherwise, we will go find one. Okay. All right. The next is another document that had gone through working group last call, and this were the cozy contexts for BPSec. So as a reminder, BPSec 9172 is the overall description of security blocks for bundle protocol, but it relies on security context to determine how information is put into and pulled out of various cipher suites and how cryptographic materials are captured. So the 9173 documents default security contexts, and they are intentionally limited in scope. They are symmetric keyed encryption and MAC algorithms, and the way in which AED is handled is also intentionally of very narrow focus, because they are meant to be a sort of a least common denominator default. And importantly, the default security contexts do not have any sort of concept of asymmetric key or PKI integrated security. And that is something that needs to be present, security context that can support that. And rather than try and reinvent that wheel in DTN working group, we decided that the adoption of CBOR object signing and encryption COSI already provides all of the syntax and semantics that we need. And so the work being done here was to create a security context that maps COSI into this ecosystem. So to that end, there were some final updated changes, or the last changes as was in working group last call. We added a scope parameter to allow the use of indirect block references as we do binding across different blocks. We added the mention of KID context header parameters for identifying keys. And there are a couple of small sort of open issues related to this on the GitHub project, although in all honesty, I'm not familiar with these. So if you have questions about them, take them to the mailing list or ping Brian on them. The important point is the last bullet, which is that none of these issues change the actual context definition or processing. So we don't think it has a significant impact or any impact on the document itself. So from that perspective, we have also done implementations of this. There are other implementations of this going on, and that seems to be not problematic and good from an implementer's perspective. And so at this point, we have the BPSec COSI context. They are not meant to replace or supersede the default ones. The default one is called the default because it presumes that there will be other ones coming in. It gives us, BPSec in a PKIX environment, particularly in the near term. And it does not address policy and what is required from a policy perspective. There's other work from that. And it is currently through working group last call with no additional comments. So I think just like the original or the ACME document, this one is meant to go forward. So having gone through working group last call, we are also looking for a shepherd for this document. If you are interested in being a shepherd, please let us know here or on the mailing list. And I will pause and say, while we are all here together, if there are any additional questions or concerns on the security context that were not brought up in the working group last call, please take a moment and let us know now, or please take a moment and put them on the mailing list.
Can I add one point about shepherding? It is not difficult. I believe I did the shepherd write-up for one of the DTN, I think DTN MA document. I did it in the airport while I sat up between security and the actual plane. It does not take long to do if you've read the document beforehand and you've had relevant conversations with people. So please, it's just really useful to have an independent shepherd to perform the write-up and make sure that the due diligence has happened. So don't think it's going to take months of your time.
Indeed, thank you. And then the last presentation here is on the concept of the early and emerging concept of bundle protocol endpoint ID patterns. And the background on this is that the use cases that are coming in motivate the need for some way of identifying sets of endpoint identifiers. As we have looked at policy for security, policy for matching, policy for quality of service, the question becomes, how do you not do direct matches to endpoint identifiers, but how do we glob them in some particular way, and what are the regular expressions therein? And how do we make sure that the definition of an EID pattern is not simply something that looks so close to an EID itself that there could ever be confusion of pattern and identifier? So that is essentially what we are doing here, or what Brian is doing here. These are purely text-based, and the pattern matching syntax has sort of a network effect. This proposal has been put together. This proposal is compatible with the IPN scheme update, which is good. And these are the various ways in which patterning is important from an identifier perspective. It's certainly something that's useful when we're doing security identities, route blocks, and authorization, but then also the configuration and policy that we've talked about. I'll leave this up here just for a moment. The other thing I will mention on this slide is that there is a difficulty here when we want to match between the different URI schemes, in particular at the top first bullet under security identities, where we talk about DTN colon or we talk about IPN colon, and how would we make sure that if a node is known by two different identities, say a DTN or an IPN URI, how do we match or apply similar policies in those cases? So in Brian's proposed drafts, then he has started putting together a couple of these individual capabilities with patterns, IPN scheme patterns and DTN scheme patterns, where you can do match all syntaxes of IPN colon with stars, or below DTN scheme pattern matches with DTN colon and stars. But then separately separate for IPN the ID into single integer parts, and each part can be exact match, match all, or one part wildcard, or range expressions, and deal with and use the compressed CBOR encoding for integers, and then essentially just try and build out a simple set of logic. Pattern A contains B, or pattern A overlaps with B. For the DTN scheme, it is a little different, separating it into name and service path segments, and then each of those can also similarly be exact match, or match all, or match parts. But the and then I again set logic related to the regular expressions. And here are some examples of what we would talk about from a DTN perspective or an IPM perspective. Singleton patterns still look like they're singleton instances, and then all services, we can have dot stars, or one service on any node pointing specifically to the IPN, star dot, say 5, and then also getting into complex wildcarding patterns and ranges and mixed patterns. So an important consideration here, particularly if we go back and look at singleton patterns looking a lot like the identifiers themselves, we need to understand that an EID pattern is not an EID. They cannot and should not be used interchangeably. This is clearly a security risk, such as the wildcard DNS names in the early PKX certificates. The syntax has been designed that a range or an expression is specifically not a valid EID pattern per ABNF. More importantly, the EID pattern is a superset of the EIDs. Its design goal is that an EID is a singleton matching pattern for itself. And then the patterns are conceptually simple, as we just saw in the examples, but they can become more complicated in practice. The IPN pattern special considerations has 3 logical parts. So the patterns always have exactly 3 components. So at this point, the question that we have is, well, at this point, there are 2 things. Number one is whether Brian will be angry at me for murdering his slides as I've tried to present them for him. But second, when we talk about the idea of patterns and EID patternings and the URI patternings therein, is this valuable? Do we see the concept of patterning as relevant to the use cases for which they have been proposed? And are there any issues with the syntax and the pattern syntax that are proposed? So I think that the question first off is, conceptually, do we think that this style of patterning is the useful style for the purposes to which we are putting this document together? Any questions or comments on the utility of patterning from that perspective? All right, Alberto, you're in the queue.
I just wanted to say that that I do support these. I think there is value in grouping, and the formatting. It's a common standard when you are playing with dealing with numbers. It's heavily used in the telephony industry, so I think both useful and the style seems to be the right one.
Thank you. And Rick?
I'm going to say pretty much the same as Alberto. I think it's useful. I think what helped it make sense to me was the understanding that the patterns really are for users and user tooling to interact with the textual representation of EIDs. So this is not specifying the internal implementation that needs to happen within fast lookups within a BPA agent or anything like this. I assume that was based on my understanding, and I kind of need to take that to Brian. So my concern is where this interacts with routing, where people suddenly start trying to do path route aggregation and try and use the pattern syntax as part of some sort of it within a routing protocol. That's where I will become concerned. But defining a common textual representation to describe EIDs that match the following pattern, I fully support.
I do see under the use cases, the routed blocks and authorization, the same purpose as IP setter notation and slashing. So that is something
that
to
worries
allow
me. That worries me simply because if I've been working on IPN quite extensively, and you've got a 32-bit space for your node numbers within a single allocator ID, and we know from the public internet that IPv4 addresses had to introduce structure in order to manage aggregation. I'm not sure patterns solve it without sort of some kind of bit mask, so there's some sort of logical operation stuff that needs to happen in there, particularly for IPN and DTN and regex. Yeah, sure. It's a good first start. I do support this work, but I think having published this, it will open more questions, which is a good thing.
So agreed, and an observation being that the fact of pattern is different from whether it is appropriate for a particular use case. Since we did go through these slides a little bit quickly, I would just keep this on the slide on the screen and presenting just for a moment as the examples of the proposed patterns. And while this is up, are there any concerns about this as this as the patterned approach, or any concerns with these as examples of what is being proposed? Scott?
Not a concern. I think this is very good. I think it's nicely compressed and potentially very useful.
Excellent. I do see that, Brian, your connection is working now. Is there anything you would like to add?
I don't know how much you've covered. It looks like this is kind of the end, but this doesn't have a lot of implementation experience yet, and there are some other things that are being worked, and the GitHub repository that's associated with this draft has an issue tracker and has some items already in there, but people are welcome to provide feedback and especially the aspects that haven't been looked at in much detail yet are kind of related to one of the things that I had posted on the mailing list, which was how to handle unknown schemes, if that's something that we want to deal with in this kind of situation. Just as well, with a BPA shouldn't catch fire and explode if it sees an EID with an unknown scheme. There are possibilities to handle arbitrary schemes in patterns using the double asterisk, and we can talk about it on a mailing list, but that's the kind of thing that hasn't been really looked at yet. So it's not a matter of if, but how.
And Brian, one of the questions that was asked before you came in was, what is the proposed use of patterning in routing here? Because there were questions as to the use of that.
Yeah, that's an interesting point, and it's almost the way that sitter notation now is used as configuration seems like it was probably not the original intent, but it was a mechanism that was common enough in tools that although sitter started out being this is a routing block, what it now is when a tool needs configuration of IP address space, well, we use sitter notation because we understand how to read that as a human, and we understand how to handle that with tools. and this is kind of the opposite direction, which is that you could use these patterns in configuration or in protocols for routing, but the intent here is not to. It's the opposite direction of how CIDR evolved. It's saying, here's a mechanism for doing patterning, use it how you will, and one of those ways of using it probably can and will be for configuring forwarding and routing, and also authorization, because that's one other thing that has been evolved over the years in the IP world related to resource PKI and authorizing. My router is allowed to forward this kind of traffic to these addresses. I am the authoritative holder of these hosts. These hosts live behind my router, and these kind of patterns would be suitable for doing that same kind of work.
Oh, excellent, thank you. And one other element that just came up in the presentation of this was, could you explain a little bit more about, for the DTN scheme patterns, complex or unavailable set logic?
So this is something that definitely is going to have to be worked out in the draft, and what it amounts to is that when I'm dealing with numbers and number ranges, it's very easy to say range A is smaller than range B, or range A contains range B or overlaps with. When it comes to, because the DTN authority part is really not specified fully, does it have structure? What is the structure? Right now, the mechanism proposed is to say, well, we can either match all or we can use a regular expression. And that's a large jump. And when you start dealing with regular expressions, what that means is that you can't really say easily, at least as far as I know, in a closed form, is regular expression A a subset of B. It's not a closed form thing. Now, regular expressions aren't the only way to pattern match a string. And if the DTN authority part had a known structure, if we were to say, in the same way as the IPN scheme has been kind of updated and refined, if we were to say for the DTN scheme, there is a structure, it follows the same approach as DNS names. It is not a DNS name, but it has the same kind of hierarchy to it. Then we could do some specific pattern logic related to that hierarchy, but it doesn't exist right now. And as far as this draft is concerned, one thing that might fall out of it for the sake of expediency is to say, we're not going to deal with DTN scheme patterns right now. We're just going to say match all within a scheme and an IPN specific pattern. And that will go pretty far to start with.
Okay, thank you. And then lastly, because you did come online right at the end at next steps, would you like to speak to the next step slide?
Sure, yeah. I think feedback is the most important thing. And one piece of feedback might be, we don't know enough about the DTN authority component to dig down into this level of detail. And we should just say, focus on the IPN scheme, focus on what has usefulness right now, and deal with other schemes later on. And that would include potentially IMC or any other scheme in the future.
All right. Thank you. Thank you very much. All right. Josh, quick question.
Yeah. Can you bring up the IPN pattern real quick? So in relation to that, I could have missed it because I was kind of talking over in the chat a little bit. So is there any reason to have any patterning in relation to the service number, or are you just particularly trying to play with the main segments?
Oh, so they're actually each of the three parts are handled symmetrically. So the examples are really focused more on the node numbers, but it applies to the same to the service numbers.
Okay, copy. Thank you.
And that is something that I don't think it was mentioned in these slides, but these kind of patterns would also be useful from an application perspective to say, register me for these endpoints, because there are some use cases where an application might need to have more than one endpoint on the same node.
Yeah, I was going to say this patterning is basically what we use internally for DTN me as well. So definitely like it. Kudos.
Thank you.
All right, thank you so much. And then our last topic is me talking a little bit about a summary of use cases related to store and forward coming out of 3GPP. So we'll go through these somewhat quickly. There is in the 3GPP, there is several working groups. One of them is SA1. SA1 focuses on requirements. The SA1 group published a requirements document that included, among other things, use cases and aspects related to store and forward satellite operations for delay tolerant communication services. And that will be the focus of what I wanted to present here. And the reason for that is when I was at 3GPP a few weeks or maybe a month and a half ago and was talking with members there, they were not aware of the work that was being done in IETF in this specific area for store and forward. And so it would be good to understand whether we feel these use cases from this community are things that are relevant to the work we do here. So in that, the document has an overview and the specific store and forward operations overview is presented here, and then that is a wall of text. But the point I wanted to pull out is this last bit. This is particularly relevant for delay tolerant IoT services via the non-geostationary space segment. And so this is not something that they're looking at from I think a real-time voice or streaming perspective, but the idea of messages and other IoT-based traffic. To that end, if you were to go into that document, which is publicly available and all the way at the front, the document can be found by looking up TR22865. There are many versions of that. The most recent version is 19.2.0. So everything that is in this presentation is pulled from that document. They talk about many use cases. The ones that are particularly related to store and forward are summarized here. Mobile originated and mobile terminated messages, the store and forward service between a UE with satellite access and an application server for a delay tolerant non-real-time IoT service. So in each of the use cases, they do have preconditions, they have examples, they have post conditions, and sometimes graphics that go through the data flow and sort of some of the justification for them, and then additionally requirements associated with what it means to go into those use cases. There is additionally inter-satellite use cases, and the text in the bullets here is also pulled directly from the document. To expand the market of delay-tolerant IoT devices, store and forward operations are necessary to be developed to sustain the user data plane during the feeder link disconnectivity. There's another for data transfer for IoT devices in remote areas where it is the thing communicating up and through and back down again because of the nature of the remote area that is the cause of the disconnection, and then some emergency support scenarios. Again, because each of these use cases comes with a series of requirements, here are some examples of the kinds of requirements that are in the document. The document is not tremendously long, but it's about 45 pages and of things like this. And so we talk about, or we see in the requirements, support for store and forward operation, support forwarding of stored data from one satellite to another satellite, support for a store and forward data retention period and data storage quotas, configuration and provisioning specifically required QoS and policies related to how these things would work. And then in addition, the document has 4 purposes. One of them is the store and forward operation, but there are other use cases that come in that also have some level of interaction with satellite communications that are otherwise supporting the store and forward use cases, like LAN access over satellites or information exchanges between ships at sea and things of that nature. And there are a couple of use cases associated with that. So the presentation here and why we wanted to bring it up was really informationally to make sure that the delay tolerant networking working group was looking at and trying to understand the statements of need for a delay tolerant communication service coming out of the 3GPP. The SA1 are requirements. There is another working group in 3GPP called SA2, which is architectures. There are a series of architectures being proposed for this by the various partners in the consortium. I think there were, last I checked, 20 to 25 different architectural proposals to this. But one of the questions that we have at large is, how do we make sure that that community is understanding and aware of the standards that we are producing here? So this is simply an informational brief for that effect. But if there are those who have more and additional details to this, I would love to hear them and invite anyone up to the queue to comment or to comment. I see Charles in the queue.
Yeah, Charles Eckel, and thanks Ed and Eric also for bringing this to my attention. For those of you who don't know, I'm the liaison manager in IETF 3GPP. So now this is at least on my radar. Actually, I think at this point everything seems to be pretty good. I looked at the SA2 documents and they reference a lot of the DTN work and have kind of placeholders in there for certain things. I don't know specifically about store and forward though, if they've done anything, but at least they have kind of, the basic stuff in place using the work that's been done in this group. What we could do is have an actual liaison to them saying, hey, we've looked at your use cases and this is how we think it could, you could leverage the work we've done. I just noticed this document that you were referencing, the TR, that's kind of the output of a study. It's not actually the normative specification. So the next thing I wanted to do was go and look and see if this made it into a TS, one of their normative specifications. And at that point, that's when SA2 and the other groups would start looking at, hey, they'll be looking at how to address these requirements. And so from, I think probably the interaction would be more at SA2 and the other groups than with SA1.
And any help in understanding exactly who those points of contacts would be and how we look at the most appropriate set of data would be much appreciated.
Okay, yep. I'll definitely be communicating with you on that. And like in many cases, people interacting across both groups is often, even better than a formal liaison. So we won't do that unless it really seems appropriate. Yeah. Yeah, thanks.
Right. Thank you very much. I see Jim in the queue.
Thanks. My name is Jim Reed, and I'm sorry, I'm a bit of a newcomer to this working group. Just to let you know, there's some other kind of activity in this area going on in ITU, specifically in study group 13. And there are various people there, mainly from China, that are trying to advance the cause of satellite communication, quality of service type activities there. The work that's going on there is very poorly specified, and the documents are almost incomprehensible. It's just, in my view, very low quality, but we need to be aware of what's going on there, at least to try and stop them doing bad things.
Much appreciated. And follow-on links to that, either directly to chairs or to the mailing list, would be appreciated. Jenny in the queue.
I just want to make a comment. I know you were at the TVR meeting, but there's someone who did a presentation and they were talking about, the use case of the inter-satellite links, how they recognize at 3GPP that it was a very important thing to consider, but they consider it out of scope at this moment. So I think it'd be interesting, when we're communicating with them, the use case they're interested in, but especially the ones that they want to focus on near term versus what they consider. We recognize it's important, but we don't want to work on it right now. So that's all. Thank you.
Oh, fair enough. Yes, in the TVR working group, the observation was that TVR would be interesting in schedule annotation, but that some of the work that 3GPP is investigating here would be out of scope for that working group. But I do think the store and forward would be considered relevant and in scope to this working group. Rick.
I haven't. Well, store and forward means so many things to so many different people. So many different things. I think their use case is fairly bounded. It's store and forward during satellite handover or during a lack of coverage, and they're really talking about 3 hops. BP may be considered overkill by them, and a certain element of not invented here. I'm all for liaison. I'm all for suggesting that we are solving broader problems than their use case, but we do have a solution. I'm interested to see where they. I'm interested in maintaining this and staying abreast of this. Sorry, there's a ramble, not a comment. I'll excuse myself from the from the list. It's getting late here.
But to Jim's earlier point, I think that the communication and the conversation is how we come to the conclusions as to whether something would be too much or too little.
I think that was my point. Thank you, Ed.
And there is an additional topic which is not currently covered by these use cases, but is one that is very relevant to the work that we are doing. And it has to do with lunar surface, 3GPP systems in the lunar surface. So there is going to be a store and forward no matter what in that context. And those, that specific use case is not considered NTN, but technologies might be the same. So it's something to also bring up as part of the conversation.
No, that is an excellent point. And part of the conversations, the early conversations that we've had to date with members of SA2 were, if there is a solution that works for the smaller use cases today, but would then persevere to solve the coming use cases that we see, then that is probably a good thing.
Yeah.
All right. We have 5 minutes of open mic. And in case we don't have something to discuss specifically in an open mic, I will share a walk-on set of slides, which is just an update to where we are with some of the network management work. As the head mentioned at the start of this session, the DTNMA is progressing forward. We have presented it with NetMod, and from that background perspective, we are now actually version 13 of the DTNMA, which incorporated discusses and other comments and AD reviews. We have just recently adopted the data model and the URI encodings for that model. And there are implementations of this that are out in the wild in a variety of ways. Overall, the DTNMA topic areas, as we've talked through data models and operational data models and value exchanges, continues to go through quite well. But the work is not complete. The ARI and AMM documents are just now working group adopted. So we are working through additional open issues here relating to translating ARIs and semantic types and type matching, and finishing up the work on authorization through access control and whether and how we do any additional CBOR tagging. But what we do have is a fair bit of implementation experience with this in a variety of experimental systems and technology demonstration systems with multiple implementations from independent parties, and that has gone well. And at this point, the work through the adopted documents, AMM, ADM, and ARI, is to complete them, complete the various open source implementations of them, and proceed. So those are the most recently adopted working group documents. Eric.
As a matter sort of related to this and sort of maybe related to AOB, I was wondering if you had any thing to share about how your presentation in NetMod went.
Oh, indeed.
That kind of stuff.
So I think it went well, but I will also invite anyone else who is in NetMod to chime in on that. The overall presentation was without any concern. The questions that came up were all supportive questions. The comments that came through were similarly supportive. Everyone seemed to understand the goal of command-based in the environment that we are in. And then speaking afterwards with NetMod chairs, they affirmed that this was an appropriate thing to be doing, that this should be done here and not in NetMod, just as other working groups would create their models, and then we should be doing this with NetMod review to make sure that we are trying to capture the things that can be captured in Yang correctly. And then finally, and understanding that Yang next is coming. And so if we do see things that have been difficult to model with Yang, that we are invited to create issues associated with that to be considered in the multi-year effort that would be Yang next.
Interesting. Thank you.
Yep. All right. With that, we have 1 minute remaining. Any final comments or walk-on topics? Rick.
I'm going to jump in because having painfully gone through the experience of adding one extra integer to the IPN scheme, I'm wondering if anyone, and I don't want to say Brian because Brian does so much, we need to look at the DTN scheme. You know, there is a number of implementations out there. This stuff is flying. We need to get a bit more maturity in how we specify EIDs. Brian mentioned DNS form, DTN registration. I don't know. There's a whole area there. Currently, there's a lot of, well, we do it this way and not a lot of best practice. So I would flag wave for somebody to look at what on earth is a DTN URI? What does it mean?
Fair. And Scott?
Just to speak to Rick's point there, it makes sense kind of architecturally that if we're going to consider DNS-like names or DNS structured names in the DTN scheme, that perhaps we should also engage the DNS community and see about maybe a record type for that. There was some talk of co-opting the old CH record type, the ChaosNet record type. But I think it's probably cleaner if we're going to be giving them DNS names to make accommodations for that.
Can I just clarify one thing?
Yeah, go ahead.
I meant just the DNS textual representation format, not actually tying them to some kind of record. That's a whole part two, or parallel work. So yeah, interesting stuff.
Agreed, yeah. But
so now,
the eventual users are going to want that lookup function on traditional internet, I'm really sure.
I agree with you, but some disagree. So let's have that discussion.
Absolutely. Let's just have one more with Jim.
Yeah, thanks. I am one of those DNS people. If you want to get a new DNS resource record type, there's a lightweight process for this. You don't even need to write up an RFC. So getting a new resource record type is relatively simple and quick. It can usually be done in a couple of weeks.
Oh, that's terrific. So this is an excellent open topic. It is something that we do need to start considering. And please, let's see that considering done on the mailing list. Otherwise, we are 2 minutes over now. Thank you, everyone who has joined both in person and remotely. And we will see you at 1:20. Thank you to everyone who joined remotely and who presented remotely.
And thank you, Meetecho, for making it work. Superb. Really good.
Yes. I want Meetecho to take over the world. This has been the easiest secretary work I've done in a while. Everything's on one screen, not 4 screens.
It's fantastic. All right. See you all.
Unfortunately, I learned today that Meetecho doesn't work over a Verizon cellular network.
Well, obviously they need to go Verizon.
Caveats, don't use Verizon.
That's all right. Halfway through the net mode, just before Ed was speaking yesterday, my entire broadband shut down for 10 minutes.
Oh, that's awesome.
Yeah, it was great. 3:30 in the morning, someone thought, no one will be using the internet. I'll just reconfigure the exchange.
Obviously, we need to stop using networks.
Anyway, I'm going to leave you all to it because it's getting late here, but thank you very much, guys, and I will see you in Toronto. Okay.
See you in Toronto, Rick. Bye-bye.
Cheers, guys.
Cheers.
Because appreciate more effectively. And the right thing is something that we just standardized.